Welcome back on the SpaceInfo podcast. Here we talk about space and everything related to it. If you are passionate about space, astronomy, technology, and everything about it, you can join all our social platforms at the SpaceInfo Club or our website at www.spaceinfo.club, where tons of content and a community of experts are there waiting for you. This is the SpaceInfo Club.
The details on this one vs my my image type of thing.
Sure, yeah.
And if you look at the the Hubble image, right? Well, the first big difference that you see is there are a lot of stars into the head, right? In this area, if you see. And over here, you got no stars. And that's because basically, the aperture of the telescope, when you talk about the details, right? That's what it means. So when
in terms of distance, those stars are closer or are farther than, let's say, the others that I can see in the image.
These are all the big ones that you see over here, right?
Okay.
I think I'm not 100% sure, but the way they look closer, way closer to us.
Okay.
Yeah.
So it's not a matter of distance of the stars, but
but they are small. So let's say you don't have that star, this star specifically. I think you can see it over here in the image, but let me just zoom in.
Okay,
So
it's very small, yeah.
Yeah. So it is very small, very faint, which means that this one on the right-hand side over here is closer to us. So it's more visible for a small telescope, like an amateur telescope. But this one over here, it's barely visible, which, just to compare the scale, the power that a telescope like Hubble has. And and that's the struggle. The more data you need in order to resolve the image, right? In order to make up to actually see the certain stars that are further away, the gases that are further away. And of course, if you look at everything else, the nebulosity and everything, it's like a huge difference. But nonetheless, we can always try, right?
Yeah, let's try. I'm very fascinated by this image, and seeing this comparison, well.
Yeah, well, it's basically like a child drawing something, and then you have like a professional. You know what I mean? Like that's the big difference. But as I said, that's the thing you're dealing with because, excuse me, it is the Hubble telescope because it's in space. I'm not even gonna get into the Webb because Webb is something else altogether. But the amount of detail and the fact that they don't deal with light pollution and all that helps a lot. But let's say if you have Hubble on the ground, you still wouldn't get the details as clear as this one because of the atmospheric turbulence.
Yeah, that's exactly what I was going to ask you. Yeah.
Yeah, so that's the thing. And then the next one that I have, and probably on this one I'm a little bit more educated, so to speak, in terms of why it's happening in this image. So this is the Bubble Nebula, and this is also a Hubble shot.
Okay.
And if you look closely over here, right on the left-hand side of the image, in the top of the bubble, that's a star that creates all this havoc around.
Okay, yeah, that's purple star on the left of the
yeah, and then my image of that specific target, I'm having a hard time over here finding it. Okay, so we got it. All right, so again, like the differences are striking between the Hubble and amateur telescope, but you can make up some details over here, and let me go like that. So yeah, but the issue over here, that's why is this solar wind and all these crazy gases going around, swirling around because of this star almost to the middle. And you can see this in my image as well, just a little bit, of course. Um, and again, that the same thing applies, that the aperture of the telescopes, they cannot be compared.
But also, is it also a matter of filters that you use? Well, also, just as a side note, as you were talking, I was just going to give a more precise data about the distance of this nebula. And just for the people who are listening, it is like 8,000 light years away. So yeah, we are looking at something that happened 8,000 years ago. And
Yeah, yeah.
yeah, as I was going to say, yeah, this difference is okay. In details, you quite clearly explain why there is, but is also a matter of filters used in processing the photo.
Yeah, it is a matter of filters, but again, what you're dealing with amateur astrophotography first and foremost, of course, is the equipment. You know, it's how should I say? It's okay. It's not only the equipment. Primarily, it's the fact that you are on the ground, so you are dealing with the turbulence from atmosphere,
Mhm.
which basically affect the image in many ways. And when it comes to filters, I don't know if you remember we spoke last time that the biggest difference between a color camera and a monochrome camera is the signal to ratio.
Yeah,
And the monochrome camera captures 4 times more data than a color camera. And that helps you, that gives you a little bit more data to work with, which translates into the image getting more clear, being better, right? Um, but if the filter, let's make a comparison. I don't know if the windshield is full of mud, let's say, or a lot of mud, you're not gonna be able to see in front if you're driving. Type of that kind of comparison. So it doesn't really matter what you use. You're gonna hit a point where that's the best you can do.
hmm,
Uh, that's also that's also valid, by the way, for Hubble, but at a different level.
yeah, on a
So in
different
other
scale.
words, well, yeah, like the comparisons are obviously ridiculous, but imagine that it's as much as at one point you hit the diminishing return point, which means that doesn't matter how much more data you compile, you're still not gonna get extra information for you to be able to have like a clearer, better image. At one point, it stops. So
Yeah, it's like a bottleneck basically. You can throw so much data, but you have other kind of limits, which may be, let's say, on the computational side, or as in this case, on the
no, but
instrumental side.
to again to put it in perspective,
Mhm.
imagine you're looking at a painting, and that painting, I don't know, you take a picture of that painting, and that picture, let's say you have the best sensor on the market that you can see every pixel perfectly, let's say, right? So
Okay.
once you hit that point, you cannot get better than that. That's the end of it. You know what I mean?
Yeah,
Like,
sure. Yeah, yeah, I know. Okay.
I know it's a little bit difficult to comprehend from my point of view, at least. Uh,
But yeah, no,
but yeah,
I think that you gave a great explanation. Yeah, at least I have now a better idea.
another thing is that, and I think this is a better way to explain when it comes to the Hubble and Webb, right? And I got
Okay.
over here the pillars of creation, of course.
Yeah, this is probably one of the most famous things.
Oh yeah, probably. It made Hubble very famous. But and of course my image, which is you know, which
I
is
don't
all
know.
right.
You still say keep saying that they are not as comparable. Okay, I can see it, but I'm very fascinated. Maybe because I never got to obtain also those images that you personally
No,
obtained.
I think we all astrophotographers suffer from this.
Okay,
You always want to get better and better and better, and I saw that. I was like, at one point, I got an image. Like when I got this image, I was fully amazed because I was able to photograph the pillars of creations in this with a different telescope with a smaller aperture, right? So this
okay,
is about 900 millimeters, and the picture, imagine it was as full as the whole screen, but I just cropped it as is right now, so
okay.
almost double than what you see over here.
Wow.
And if you look at this image compared to this image, right, which let me put the, yeah, this is much closer. So the telescope goes way deeper because the aperture of my telescope, the focal length is 2000 millimeters on the
Okay.
big one, right? Uh, this is the GSO, the 2000 millimeter, and this is my Orion telescope, 900 millimeter. And I love this image, right? Like I was fascinated because the first time when I tried to shoot the Eagle Nebula was well, I could barely see something. So, but the more you make progress, the more you want to get better
Yeah,
at it,
sure.
which is normal. But you have to be to understand that there are certain limitations, and that's what a lot of astrophotographers are fighting with. That they want
Yeah,
to get better and better and better, but there are, as I said, there are certain limitations. And at
which are
one
hard to
point,
accept.
yeah, at one point you are just you're hitting a wall basically.
Mhm.
So that's the thing that you have to deal with as well.
Yeah, just a couple of things that comes to my mind. Well, you also did those images. You got them from New York, right?
Yes,
From
yes,
Queens. Okay. And
yeah.
how much exposure time did you take?
This one that you see over here on the pillars, it's not actually a lot. It's like about 18 hours.
Okay.
And another thing that I've been working on, and that's very important to have a software that helps you take the photos. That, let's say, I took this photo probably like about 3 months ago,
Okay.
and let's say that I want to take another one tomorrow. I want to take another 10 hours. This software that I have, I can actually put this image into the software, and the software would identify the exact framing of the target, the exact
Okay.
location, and it would send the telescope there. And I would be able to add to the data, I don't know, from 2 years ago, let's say, I can still add continuously data to this image.
Oh, that's very,
Uh,
very powerful.
It's very powerful because, let's say, I don't know, next year I have 100 hours.
Mhm.
You will see a huge difference in this image. You will see more clarity. You will see more gases going around. You will see more stars, right? You remember when I was
Yes.
showing you
Yeah.
the horse head? You're gonna
The first
resolve
one. Yeah.
more stars, and basically that's my approach. I've been like, okay, so just add, pile up data, pile up quality data, and eventually we get a better picture. Uh, but if you look at Hubble or a Webb, I think they pointed the camera on the Webb, I don't know for a few hours on this picture right here, right? So it's just
Wow.
I know, yeah. And that's what I meant to say when I was talking about Hubble. Believe it or not, Hubble is getting obsolete in a way, because I think he doesn't have the infrared, and I mean, he does have the infrared, but Webb has like a lot more tools.
Yeah, and also the bandwidth it's much more extended on the web. So yeah. even though tools are different, also the frequencies and the bandwidth.
Yeah, this is crazy. These two pictures, I find it fascinating because this is the exterior that you see on a Hubble, and this is the interior of the pillar. So it kind of peers through certain gases, and you get to see other details. And that's why it's so fascinating about astrophotography, though, because the more you get, the more you get into it, the more you discover. It's like a never ending treasure box, you know.
Yeah. Also, I really like this let's say this word that you used, because when you say that it allows you to look inside, yeah, basically it recalled me when I talked with some people that built the Webb telescope, and they were so excited to tell me that exactly the infrared is what is like the main thing that will allow us to look for life, because it's with this frequency of light that we can look for extraterrestrial life. And yeah, I think that looking inside thing for a sort of treasure box is the best image that we can imagine. And also by looking at it is so fascinating.
Yeah.
You can see
No,
actually
it
it
is.
seems that there is a hole below the three pillars that you cannot actually see in the Hubble image.
Which one?
In the center of the image, yeah, just yeah, where you have now the pointer, it seems that there is a sort, let's say, a hole where you see stars through it, which is not present in the Hubble one, and it gives you the idea of how deep you can look into it.
Oh, no. It's just crazy. Your mind bends if you try to. I mean, of course, that's a fascinating thing that I said. Like, let's say you travel to this nebula, right? If you go close, you're not gonna make up the pillars anymore if you would be that close. So everything would the space around you, basically, it will run away from you, and when you would get inside, you know, basically nothing will look like this, like, or close. Let's say you are close. Let's say you are 100 or 1,000 light years away from it. Maybe you can still make up the pillars, but the closer you get, that would dissipate. I mean, that's at least that's my interpretation of it. And I also like to do these videos, the 3D type of videos that I have over
Oh
here.
yeah, I've seen it before. I hope
Yeah.
that you're showing it.
And a lot of people are like, oh, this is not accurate. Of course, it's not accurate. This is like an interpretation of how it would be to be at a distance away and kind of, fly towards it. But I don't think that would be possible. Let's say if you have you are in a starship
Yeah,
and you
it's
look
like
outside, I don't think you would see this. You know what I mean?
yeah,
But it's just
probably it
another
would
way
be
of
also.
presenting the photography to people.
Yeah, and I like this a lot, because there is also there is the acquisition part, but also the artistic side, and I like it for this because a lot of people can take almost the same image, but the interpretation that you give is what makes it special, at least for me.
Yeah, I believe if you watch a trailer of a movie, or uh, if you watch Interstellar, for example, the sequence when they run away from the black hole, or when they get to the black hole, the music and the whole artistic side of it, and it makes your hair stand up. Like, if you would see that scene probably without the music, and the cinematography would be like dull and stuff, you wouldn't like it. So I think makes people kind of, if you present your pictures this way, it makes people get into astronomy
Yeah.
more and appreciate it more. And I think that's why at the end of the day, like, I can't say I'm looking for a scientific accuracy 100%, even though I'm trying to not to alter the picture if I can at all, just try to be accurate. But many times, you kind of skip some steps and be like, okay, let's make a video like you are flying through the nebula, but that's not such thing. That, like, in reality, that wouldn't look like that.
Yeah, but
But I think it makes it looks cool. It makes people get into astronomy, that's the reason why I think I'm doing it.
yeah, and then also that's why I think so much people are passionate about it, and also people like me who don't have all that time to dedicate are still fascinated to see it. I was just mind blown when seeing it.
Yeah, and I have another one that is one of my favorites that I've been working on. This is the Cone Nebula. I don't know if I assume you are familiar with it, right?
A little less than the others, and I'm getting very curious. I've seen it a couple of times, but I'm not very familiar with it.
Yeah, it's the Cone Nebula. It's a little bit harder to get, and in my so if it's closer, let's say, and it's brighter, usually that's the most important thing. If it's very bright, usually it's easier to capture. And of course, this is the Hubble telescope image.
Mhm.
And in my opinion, this is like my favorite. It looks like a dark priestess somehow. It's like it's just a crazy, like a crazy visual that he has. And this is the picture that I got with my big telescope. And I'm very happy in a sense that I never actually thought I will get this close because it is very, very small. Usually it's called the Christmas tree cluster, Christmas tree nebula, and
Oh
it's
yeah,
like a
yeah, yeah,
huge,
yeah.
yeah,
I say yes because I was looking for it while you were talking, not because
right, right,
I knew
right.
it.
And then it's
Yeah, it's
and
Christmas tree
this
cluster.
one is
Yeah,
like in a center type of not in a center. I would say it's a little bit in the bottom of it, but it's a fascinating object. And I was very happy to actually to get so close and be able to take a picture of this one.
yeah. I really like it. Also, all the stars that you have around it are
Mhm.
gives it a lot of details, and yeah, just I have no words.
I was very happy though that basically, if you go close over here a little bit, you see the top, the two stars, which from
Okay,
the
that
image
you
over
can.
here,
Yeah,
I think from the Hubble looking over here, I think that the one in the top might be a double star system. It looks
yeah,
uh,
like a twin star. Yeah.
twin star. Yeah, it looks like that, but I'm not sure. But and if you look around, obviously, it creates a lot of havoc over there. A lot of solar winds that are basically eroding the head of the cone over there. Excuse me. But yeah, when I saw these two stars over here, I was like, oh my god, I finally got them. You know, well this time because I've been trying several times. I mean, for me, uh, it's like a baseball type of thing. You
Yeah.
go at bat for 5 times and you hit once. Sometimes.
Yeah, so but which were the problems at the beginning with this image, for example?
It was too dark. It was
Okay.
too dark. Yeah, and it's a little bit of. I'm trying. Let's see if I can. Just give me a second because I'm gonna
Sure.
access my pics inside to see if I have. I wanna
Yeah, just
bring this
while
out
you
of
are looking
the.
for it, I'm just saying for the people listening that the Cone Nebula is a region in the constellation of Monoceros and was discovered in 1785, like 250 years ago by William Herschel, and yeah, is something like in terms of distance of 2,700 light years from our planet. So that's quite distant, but we have seen different images at the beginning of video, which with stars that were farther away.
Yes, yes. And again, it's the size that makes a huge difference. And I think for the first time, I don't think I got a chance to show you this last time, but this is basically, these are the raw images. And I'm gonna show you on the right-hand side over here, when I'm pointing, this is the hydrogen alpha data. And you can see it from the start when you look at it. This is the more pronounced, like you see details already.
Also around it, yes.
Yeah, if I stretch it a little bit more, it's gonna create a little bit of vignetting. These are like technical stuff that in astrophotography you have to be careful. That's because of the flats, the calibration frames. Probably they are not 100% good. But you can see the details. You can see all the gases over here. If you go close in a monochrome image, you can see the details beautifully. Sometimes I love to just check out details in a monochrome image. And then if you go to oxygen, you see nothing, basically.
It seems a completely different image.
Yeah, it's just you see the same pattern of stars, right? That you see in this image. Because if you take this image and you put it in top of it, you will see that it fits perfectly because the stars are aligned on each channel. But yet all the bluish gas, so if you look over here on the right, you see this kind of blue hue around it.
Yes.
That is actually oxygen. That's why it's not visible. It's not the cone itself. It's just around, like a fog type of thing. So that is the oxygen. And it's the hardest channel by far to capture, usually oxygen, right? And then you go to hydrogen, to sulf. And then if you put this side by side, you can make up a little bit over here the details of the cone.
Yeah, it seems like that you have to know that it is, but if you look, actually, you see at least the pattern and the limits of the cone.
But to answer your question, I mean, before I do that, so usually the solve, what it does, it gives you more on the edges. It gives you more. Let me see if I can find another image to kind of show you the. Okay, do you see over here in the bottom, right? A little bit is yellow, all this yellow hue. That's basically solve, and that goes around. Yeah. Excuse me, and I will. What I meant when you shoot a target like this, you see how dim they are, right?
Yes.
If you look, except the hydrogen, which is more visible, everything else is very dim. So that's why you need to add extra data in top of it. The more data you add, the more the image becomes more clearer. It becomes better. But that's something that you have to take in consideration. For example, from New York, I think I mentioned this to you last time. It's impossible to take a picture of a galaxy. I mean, not impossible, but I got pictures of Andromeda and they never look properly because of the light pollution. And that's because I'm not using any kind of filter. So you go directly, all that light pollution invades your camera. And it's impossible to make up details after that.
Yeah, I remember perfectly when you told me about this, because it was one of my let's say my points in my mind, and I was very curious about knowing about this. And
and it's another type of a nebula that we cannot capture from the city, and that's a reflection nebula. It's one in the Orion. I forgot the designation, but
yeah. So that for sure, it's not something that we will talk about in the next episodes. But maybe if you like, if people like this kind of let's say almost tutorial in the last part, just write down in the comments. Well, maybe next time we could could go more deep into detail, talking about the software maybe. Yeah, I don't know.
Oh, definitely. No, definitely. I'm usually do some tutorials on my channel as well, and I'm trying to explain how to be done and all that. And I'll be glad to do it with you anytime and kind of get an image from the raw image like this and just make the steps, the processing. Usually it's a little bit more boring, I would say, but you can always ask questions and we can make this interesting.
Yeah, I will make the part of the students. Yeah, I will be very glad to do it. Yeah, so for this time, I would say thanks to all the people that dedicated us some time to watch and listen. And I hope everyone likes this. Just let us know in the comment. So next time we can still talk about these amazing images. And look down in the description because I will put Sebastian profile and go look at him because those images are amazing. So thanks everyone. Thanks Sebastian.